Okay, for chapter 1, what we want to do is do a little trigonometry review. So starting out, we want to, basically this class we're going to be working mostly with right triangle trig. So that'll be pretty handy for us. We will do a little bit with law of sines and law of cosines, but not an overly inordinate amount. So basically, if we want to call this the hypotenuse, and if we were looking at angle theta here, this would be the adjacent side, and this would be the opposite side. So if we wanted to find the, or well, let's just say the sine of theta equals the opposite over the hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse, and the tangent of theta is equal to the two numerators, the opposite over the adjacent. So if we know those, and we can, if we know any of those three, we can surely rearrange those to find the others. So let's keep that in mind as we work through these problems. So if we were to look at an example, let's back that up a little bit, and we'll try to get one example on this page. So if we had an example, let's say we went something like this. Again, this is 90 degrees. Also keep in mind on that 90-degree triangle that all three sides are going to equal 180 degrees. Excuse me. So keep that in mind. So if we had 30 degrees here, we know this is 90, then we're going to get 60 up here, aren't we? And we had 4 inches here, and we wanted to find this side A. How would we go about that? Also keep in mind that a couple of things here. One, I want you to keep track of your units. This is equals inch equals IN. This is feet equals feet, if you will, equals feet. Millimeters. Okay, and meter. So keep that in mind. So now if we want to solve for side A, well, let's see, what do we know here? We know that that's the side opposite of the 30, isn't it? So we've got, and we've got the 30 degrees here. So the sine of 30 degrees equals A over 4 inches, doesn't it? So if we move that, then let's see, we want to move the 4 inches over to this side, so we have to multiply both sides by 4. So the sine of 30 degrees times 4 inches, try to keep those the same, equals A. Therefore, A equals, well, let's see, let's punch that in the calculator here real quick. Sine of 30, and on my calculator I have to put that closed paren in, times 4 says that that's going to be 2 inches for side A. Likewise, if we had wanted to find, let's call this side B. Well, let's see, side B, if we don't know A, Side B is the side adjacent, isn't it? So adjacent and hypotenuse, we're dealing with the cosine. So cosine of 30 degrees equals what? B over 4 inches. Therefore, we've got the cosine of 30 degrees times 4 inches equals B, doesn't it? And we would know then that if we punch that in the calculator, it sure better equal, well, let's see. Well, I said it sure better, but we don't know yet, do we? Cosine of 30 degrees times 4, about 3.46, actually 3.464 inches. Okay, so now what we could do is do the Pythagorean theorem, take 2 squared plus 3.464 squared, take the square root of that, and that better come out to 4. So I'm just going to punch that in here real quick. But if we could say, basically, this should be a true statement. 4 inches equals the square root of 2 squared plus 3.464 squared. Now, and again, with the 3.464, that's rounded off, so you're going to lose some there. But if we take the square root of 2 squared plus 3.464 squared, 3.9 to the 4 decimal places, if you will. So that's going to be 4. So we're good there. So if we know any of those, we can go back and figure what we've got going on there using the right triangle trig. Now, the law of sines. Says this. It says if we've got a triangle here, and nothing on this is right triangle. Hit A here, C here, and B here for the sides, and we would have this side would be, or that angle would be B, which is opposite the side. This angle would be C, and this angle would be A. So we've got A over the sine of A equals B over the sine of angle B equals C, the side over the sine of angle C. So if we know any combination there, we can go ahead and solve. If we know any 3 of the 4, we can solve for those. And essentially, you're setting up a ratio, aren't you? So let's see if we had. Let's say we had a problem that looks something like this. And let's get a little crazy there. But this was side A. We had 80 degrees in here, and usually they're all signs for angles that are less than 90, if you will. 60 degrees here, 30 meters here. If we didn't know what A is, well, we can figure out what A is, can't we? A equals 180 degrees minus 80 equals 100 minus 60 degrees. So angle A is 40 degrees, isn't it? Well, let's see. So we know that now. We know we can say that A equals the sine of 40 degrees, over the sine of 40 degrees equals what? 30 meters over the sine of 60 degrees. So if we rearrange that, we could say then that A equals the 30 meters divided by the sine of 60 degrees times the sine of 40, couldn't we? We're just multiplying both sides by the sine of 40. Therefore, A is going to be 22.3 meters. So we can solve for that. 30 meters divided by sine of 60 multiplied by the sine of 40. And we should be good on that. Well, let's see. If we had one, we wanted to use the law of cosines. Trying to think of one here that we've got. Okay, if we this page down here for law of cosines, simply stated, law of cosine says that if we've got some kind of triangle looks like this, and we've got this is C, this would be C, we've got A, B, and B, that C squared, the side C squared equals A squared plus B squared minus 2 times the side A times the side B times the cosine of C. Okay, so if we know some combination of those, then we'll be okay to solve for any of those other applications. So let's see, if we do a problem looks something like this. We've got a triangle, and we had this is B, and it equals 3 meters, and this is A, and it equals 4 meters, and C equals 6 meters. Okay, and we need to find something going on here. Let's see, if we wanted to find C, and this is A, and this is B, right? So if we wanted to find C, then what would we do? Well, let's see. We got this C squared and so on. Well, do we know the side C? We do. It's 6 meters squared equals 4 meters squared plus 3 meters squared minus 2 times what, 4 meters times 3 meters times the cosine of C in degrees. Well, we don't know the C part, do we? So let's see, we're going to have to manipulate that around. Well, let's see. If we take and get these out of here, we can move these to the other side of the equation. So 6 meters squared is going to be 36 meters. This goes to the other side, it becomes a minus 4 squared, which is going to be 16 meters, and this goes to the other side, it's going to be minus 9 meters equals what? Negative 2 times 4 is 8 times 3 is 24 meters. Cosine of C. So cosine of C equals, well, we have to divide by both sides by negative 24, don't we? Well, let's see, we got 36 and 16 is 42, right? No, sorry, 52. That's not right either. 36 minus 16 leaves you with 20. Minus 9 would be 11, right? And 11 divided by 24 should be something like 0.4583 meters. Now this was a positive value divided by a negative value. It's going to leave you with a negative number, isn't it? So the cosine of C is 0.4583. So we'd have to do C equals the arc cosine, isn't it? Let's rewrite this. The arc cosine of negative 0.4583. So what does C equal? Well, let's see, we'll change that to a negative 0.4583. Arc cosine of negative 0.4583. And that's going to show up to be 117.3 degrees. Be careful there. You need to make sure to carry over that negative symbol, because if you do a cosine of 40.4583, you'll find out that that's 62.7 degrees, and angle C is obviously not 62.7. It's much more than that, so just be careful there. Okay, let's see, we got a couple more things to look at here. If we look at some geometry, some simple rules that, well, one thing for sure, that if we've got a right triangle, talked about that earlier, that all three sides of the triangle have to equal 180 degrees, or excuse me, all three angles have to equal 180. We also have a rule that says that if two lines intersect, that we've got, if we label them as such, that A equals B and C equals D. Okay, and that's good enough for that. Then we also have supplementary angles. Says that A plus B equals 180 degrees. Now I want to caution you here. I'm putting this stuff in here. I'm not going to ask you a quiz problem over what's a supplementary angle. But you just have to realize if you got a straight line and you throw a line between the two, that those two angles have to equal 180. Complementary. Deals with 90-degree angles. If you got a line going through here and you got A here and B here, A plus B equals 90 degrees. Likewise, if you've got two lines that are parallel and you cut a line through here, and we labeled these as such, A, C, B, B and D. Then we've got, in this case, we got A equals B, C equals D, and A equals B equals C equals D. And that's the main things that I wanted to look over the trig and geometry portion for chapter 1. Our next video that we're going to do will be dealing with forces, vectors, and resultants. So we'll finish this one up and go on to the next one. Then when we get on our next one again, be forces, vectors, and resultants.